This is an explosion, and this right here is a hydrogen bomb. Have you ever wondered how this small thing caused an explosion as big as this? Well, to start, there are different types of elements you can use to create an explosion. One of them is plutonium-239, or Pu-239. Pu-239 is fissile, which makes it able to sustain a nuclear reaction. Fissile materials, when they split, release massive amounts of energy, which end up causing a huge explosion. When Pu-239 is hit with a neutron, it becomes really unstable and releases 3 neutrons, xenon-134, zirconium-103, or other elements. If there are other Pu-239 around, the neutrons from the original Pu-239 can hit it, causing a nuclear reaction. Pu-239 is an alpha decay, making it unstable, and all unstable atoms are always radioactive. When in alpha decay, it starts to break down, transforming into different radionuclides, and it keeps breaking down until it is a stable atom. This is called a decay chain. The decay releases energy in the form of ionizing radiation, which is radiation with enough energy to knock out electrons. Ionizing radiation can harm atoms and living things, so it poses health risks by damaging tissues and DNA in genes. The atoms released through the explosion of Pu-239 create unstable elements that go through the process of radioactive decay. That is the reason why there is radioactivity after a nuclear bomb explodes. So another element that can be used is uranium-235, or U-235. It is unstable and in alpha decay. U-35 is also fissile like plutonium-239 and is used as another material to sustain a nuclear reaction. It acts the same way as Pu-239. These two elements are used in nuclear weapons like the atomic and hydrogen bombs. In hydrogen bombs, there is one extra thing that makes it even more powerful than atomic bombs, which is a compound called lithium deuteride. Lead is an ionic compound made of lithium and deuterium, which is a stable hydrogen isotope with 1 proton and 1 neutron. Lead, when bombarded by neutrons, produces tritium, also an isotope of hydrogen, with 1 proton and 2 neutrons. The tritium and deuterium from the mixture can go through fusion, releasing more energy from the bomb. This process is called nuclear fusion. Nuclear fusion is a reaction in which 2 or more atomic nuclei combine to form a larger nucleus. Nuclear fusion releases a lot of energy. So, an example of an atomic bomb are the bombs used on Hiroshima and Nagasaki. The Hiroshima and Nagasaki bombings killed around 150,000 to 246,000 people. In Hiroshima, about 1,900 are believed to have died from cancer that came from radiation from the bomb. Little Boy, the bomb dropped on Hiroshima, had around 140 pounds of uranium, and Fat Man, the bomb dropped on Nagasaki, had around 14 pounds of plutonium. The Fat Man had a yield of 21 kilotons of TNT, and the Little Boy had a yield of 15 kilotons. And a hydrogen bomb, called the Tsar bomb, has a yield of 50 megatons of TNT. For comparison, 1 kiloton is 0.001 megaton. The Tsar bomb is around 2,380 times stronger than the Fat Boy. So, in conclusion, don't use nuclear bombs, because if one country uses it, every other country will start using it, and that will cause a chain reaction and possibly destroy Earth in the process.